And now, section 3.5, number 31, and the directions are to find y double prime by implicit differentiation. So that requires that we first find y prime, and then find the derivative of y prime. So because they use the prime notation, I'll do the same. So this is a case where we actually could solve for y in terms of x. Y will not be a function. It will be in two pieces, like the example that I did in the video for this section. But it's just as easy to use implicit differentiation. So I'm going to just take derivatives all the way across with respect to x. So the derivative of 9x squared using the power rule is 18x. The derivative of y squared, remembering that y is itself a function of x, is 2y times, whoops, I said I was going to use y prime notation, times y prime. So again, we're really using the chain rule. We're bringing the power 2 down in front. We're taking the base function y to one lower power, which is to the first power, and then we're multiplying by the derivative of the base function. The derivative of y is y prime. And then the derivative of the constant 9 is 0. Whoops, I lost my prime there. Okay, so now I just want to solve for y prime, so I'm going to subtract the 18x over to the right-hand side, and then I'm going to divide by 2y, so that y prime is negative 18 over 2y, which I could rewrite as negative 9 over y, or I could write as negative 9y to the negative 1. Either of those is fine. So we're eventually going to, the next thing we're going to do is take the derivative of y prime to get y double prime. And so in this case, I mean, it doesn't really matter if you looked at it as negative 9 over y. If you looked at y prime as negative 9 over y, then you could use the quotient rule with that. If you look at it as negative 9y to the negative 1, then you could use the power rule. So y double prime, again, is the derivative of y prime. I don't know what just happened there. So I'm going to use the power rule on that, and I'm going to get 9y to the negative 2, but again, I have to multiply that by y prime, right? Remembering that y is a function of x, so I'm really using the chain rule. So I brought my power negative 1 and multiplied it by the coefficient negative 9 to get positive 9. And then I raised y, which is a function of x, to one lower power, that's the negative 2 power. But then again, with the chain rule, really, I have to multiply by the derivative of y, which is y prime. Now, I know what the value of y prime is. It's either negative 9 over y, or it's negative 9 times y to the negative 1. So I can rewrite this as y to the negative 2 times negative 9y to the negative 1, and simplify that. So 9 times negative 9, I believe, is negative 81. And when I'm multiplying y to the negative 2 times y to the negative 1, I can add the exponents, so I believe that will be y to the negative 3. And again, I could also write that negative 81 over y cubed. Either way is fine.